The worksheets, ma'am.
Yes, worksheet. Yeah, sorry, worksheet. Worksheet. So many worksheets from so many subjects. Yes. How do
Ma'am,
you
yes,
feel that
ma'am.
worksheets?
Yesterday night I received the worksheets, ma'am. I'll complete within Friday.
No, no, no. I'm not asking when you are complete that worksheet. I'm just asking what you feel for that worksheet. How you feel, whether it is needed for you or it is the waste of time or someone, it's like thinking that one. Yes. Not, I'm not denying you. I'm just telling all the ways on all the possible ways of thinking, like a student. If it is a bright student means he can do all those things. If I am a lazy student or I am not doing anything means I can think like this. Why I'm doing this? Even I attended all the classes, then why I'm doing like this? Likewise, so many thinking is there in our mind. Yes. Yeah. Likewise, I can ask you. Yeah, that is the same question I can ask. Neha, what is your thinking or what is your idea about the worksheet? Is it needed or is it a proper way to give that worksheet?
Ma'am, it
Is
is
it
needed,
workful?
ma'am. But only thing was like there are some questions which I do wrong and I'm not able to find what is the mistake, ma'am. So if somehow we are getting the solutions after submitting the worksheet, it will be helpful.
Okay, okay. Can you tell me one more time? I'm not getting your point.
Ma'am, that is after the worksheet, we submit the worksheet, just like
Okay.
whatever questions have been wrong, if that can be told how to just solve that question, it will be helpful.
Okay, yeah, very good, very good. But yeah, that is already I suggested in that team member. But for that, if you okay, one assignment or one worksheet, you are given for 10 questions, yes, for a subject wise. But for all the subjects, you are getting 30 or 40, okay, PCM or PCP likewise. So the 10 questions we can solve in this class, okay. In this class means what happened? Can you tell me?
Ma'am, no, ma'am, I'm not telling in the class you have to solve. If the solutions
No,
are
no, no.
sent
I
also,
am
it's
just
okay.
telling. I am just telling in this class I can solve the same 10 questions.
Ma'am, but then the
The
whole
last
class will
worksheet.
be taken up, ma'am.
It will hold all the classes. Yes, the total 1.5 hours is spent to the same 10 questions. But
Ma'am,
that is the reason I'm not taking that one. Okay. Otherwise, I could solve all the worksheet problem in this class itself. I can solve it. But only the reason is we don't have the time being. Okay. Already we can't able to finish the 7:45 itself. We can go still 8 or 8:30 itself. We can go it. Okay. Even a single day we can't finish at the time of 7:45 or 8. Okay. It is not done in my first class. I think so. So I want to reduce the time. Doing 8:30 to 8. I want to reduce my time. Okay. So that is the one. Okay. Mistake. I already noted that. Okay. Then what about Aditya? Your suggestions about the worksheet? What do
ma'am,
you think about
if
that?
ma'am, we need not do the sums in the class, ma'am. But if we can get a PDF copy of or something like that after we send the worksheets, if whatever questions we have gone wrong, we can use the
Answer sheet. You want to
PDF, yes, ma'am,
um,
answer solution sheet or
yeah, that
something.
I can send. Okay, very good. That I
That'd be
can
really
send.
helpful, ma'am, because some questions are really twisting.
Okay, yeah, some questions are really twisted. Yeah, that already okay, very good. And other suggestions, all of your suggestions are very helpful for me. Okay, because I am your physics
Yes, okay,
teacher,
ma'am.
and yeah, tell me, dear.
Anything is
Naveen,
okay.
Meenakshi, for you it is okay. Okay,
Till
Meenakshi.
now given PDFs are really well, ma'am, but as school
Hmm.
started, quite questions are less means we can do both, ma'am.
Okay, so as school started, now the school is not started, I think so, yes? So that you can do all the
Ma'am, it is
10
started.
problems in
Started, ma'am.
Started, ma'am.
started. Okay, but it
You
is
can
also
work
okay
from
for
both,
you,
ma'am.
yes? It is also
Ma'am, we
okay for
have
you, only
class
10.
till 3 o'clock, ma'am. Then again 6 o'clock onwards class, ma'am. So,
Monday to Saturday you are having?
yes, ma'am.
Yes,
Saturday
ma'am.
we are having.
Okay, very good. Monday to Saturday you are having school classes, then Guruji classes, then Sunday also you have a special classes. Okay, so many classes you are attending. And
Classes, no
is
problem,
it
ma'am.
the
Too
10
much of
question
work,
is
ma'am.
enough? 10 question is enough or you need a much more questions? Or you want to
Ma'am, actually,
decrease
those
the
10
number?
questions are like, it comes from all the parts of the chapter. So it's like, it's nice. 10 questions.
10
Enough.
question was nice, yes?
Enough.
Okay. But I thought that if it is a level based question means That is also very easy for you. First, you need to understand the one simple problem, and then the difficult problem, then most difficult problem. Likewise, you can go means you can easily go through the concept as well as you can learn how to do the problems. That was the best idea comes from my mind. Okay, if it is what they need. But
So
for
you
that,
mean like,
10 question is not enough now.
so you
Yes.
mean like 5 easy, 5 medium, 5 difficult questions?
Yes.
15, ma'am.
Ma'am, are
Yeah.
these worksheet like chapter based, like in one chapter only 5 worksheets? Is it any their limit is there, ma'am?
Notice the limit, Rakana. If you take
Because like I felt, ma'am, I don't know about others, ma'am.
yeah,
Like
tell me.
before getting thoroughly in one chapter, the
Hmm.
next chapter's worksheet is coming, ma'am. So like I feel like that, ma'am.
Yeah. Can you tell me? I didn't understand. Before completing the one chapter, you get the another
Like
chapter.
no, ma'am. Like one chapter, like I'm making it clear with one chapter, ma'am.
Okay.
But before that, the next chapter's worksheet will come, ma'am. So
Okay.
I
Yeah.
just
So
want.
you are preparing the one chapter, but the questions are coming from the next chapter. Am I right?
Yes, ma'am.
Okay. Yeah. And that was the difficulty. Yeah. Really, I understood that one because the so many actually first worksheet is came from lots of question for you. Yes. Yeah. That you really don't know, but hands off you, Dakarna. You and Neha both are written well for that worksheet or assignment. Okay, from the last of motion. Yeah, that it is very well for attending that one. Okay, all of your videos should be on. Karthik, Gopi Krishna, Pavan, and Naveen. Where is Aravind on your video?
I
Kanna?
just turned off my video.
Yeah, okay. Naveen, what do you feel? Actually, I got scared about Naveen. Have you sent all the class test and assignment? I didn't get any of your class test answer and assignments or worksheets. Naveen, can you answer me?
I'm trying to send them, but I think,
Yeah, tell me.
I'm trying to send them.
Trying to send Rakana. Class
No,
test, you wrote the class test, yes? All the class test you wrote, I
Yes,
can also see your written. But why it is not submitted?
ma'am.
You don't know the mail ID to submit?
I know, ma'am, but the school subjects are also there. So,
You don't tell like this, okay? You completed in this class itself, 8 o'clock or 8:30, up to 8:30 or completed this class itself. Then the sending the PDF or sending your answer sheet to that mail ID, it take only 2 or 3 minutes, yes? That 2 or 3 minutes you can do your class subjects, school subjects, work. Because I really didn't get any answer or any class test from your side only, okay? There was the one small complaint from you, okay? For you, okay? Yeah, so please don't do the same thing for other time, another time. Okay, dear. Okay, so yeah, so I can give the answer sheet, my dear, okay? Once you are completed, I can give the answer sheet for the question, okay? What are all the 10 questions which is given? As well as instead of the 10 question, I can give 15 questions, okay? Is it okay for you? That is on the base level based questions. 5 easiest questions that you can answer within a one single answer, MCQ level. And another is only one formula is used in that problem. And the next 5 questions, it is little bit tough. You can use 2 or 3 formulas for solving that. Is it clear? So if it is was the level based questions, you can go through the level. Okay, what is the easiest level? Then you can come to that medium, then you can go with the highest level. Okay, the level of thinking will be different because in JEE or NEET exam, you don't go with the same level. You can go with the different types of level, then only you can attend all the exams. Okay, is it clear, my dear? The 15 question is clear, or it was tough? Or in within 10 question, can I give the level based question? Which one is easy for you?
12 to 15, 10 to 12, 10 to
And more
13.
the questions, more it will understand. Okay.
Yeah. 15 question was easy. That in that 15, 5 questions are only MCQs. Okay, that you need to think and write the answer. Okay, so only the 10 questions you have to give the numerical problem. That was enough. Yes. Okay, very good. So based on that only we can improve ourselves, because in each and every test, what is your test mark? I didn't know what is your test mark also. I don't know, really, I don't know. For physics, chemistry, maths, in any subject, I really don't know what is your test mark. Can I know that?
1 second.
Range.
The last
What is
test
your
mark,
range?
no ma'am?
Yes, the range of your marks. Don't tell the correct approximate rank only I need. Approximate mark, 70 to 80, 80 to 90, likewise. You know your marks is, why you go for checking and those things?
No ma'am, taking the average.
Oh, taking the average. Just tell what is your last mark. Last mark in between 70 to 80 or what?
Ma'am, 50 out of 50 marks, last chemistry test, 50 marks it was there, ma'am. From that 44 I got.
Okay, in physics?
Physics, I don't remember, ma'am.
You
Ma'am,
know
the
the
test
approximate
means you're
value.
asking that Friday test, no ma'am?
Yes, Friday. How many tests are happen? Only one per week?
Five.
Five, ma'am.
One test a week, ma'am.
One test per
One
week,
test
yes?
per week. Yes, ma'am.
That is why I'm asking only one test per week.
Ma'am,
What
the
is that mark?
latest test I got 44 out of 50, ma'am.
Okay, that was chemistry.
Yes, ma'am.
Okay, for physics, what is your average mark in physics? How you score? How much you score? Neha, Meenakshi, you can also tell. You didn't write any physics test?
No ma'am,
We
I've
wrote,
written, ma'am.
ma'am.
I'm not able to recollect the mark.
Ma'am,
Actually,
before that we had physics test, ma'am. 21st May. For that
okay.
I scored 46 out of 50, ma'am. Yes, ma'am.
Okay, 46 out of 50. Okay. At the time only Neha and Meenakshi told 3 questions were wrong. I
Two
just
questions, ma'am.
2
Ma'am,
questions
yes
were
ma'am,
wrong.
2 questions I got that.
So then you know the mark of the test, yes?
Ma'am, I lost 2 marks, ma'am. The 2 questions.
So only above 40, yes? Above
Yes,
40
ma'am.
you scored.
I got it.
Ma'am, 44, ma'am.
Okay, very good. What is Karthik and Naveen mark?
I'm
Pavan,
checking.
Ma'am, my
checking.
first mark test alone was very low, ma'am. Others were
Very low.
good.
Others are very good. Okay.
Because the first test
yes.
I was not sure, ma'am. I was not there
Okay.
during the concept.
Okay, my dear. That was not worry about the test mark, okay? You didn't give your best. Don't like that. But you have to best in the concept, okay? Wherever some questions are asked based on the concept, you need to tell. This is the concept. Is it the right answer? Likewise, you have to tell, okay? Okay. So let's go for the chapter again. Can you tell the recap of the laws of motion? Pavan and Aravind, all of you on your video. If you're not on means I just remove that person, okay? I don't want that person in my class. Yeah, anyone just tell me the recap?
Ma'am, first we just saw basic intro of what force is, ma'am.
Okay.
Then we saw about the Newton's 3 laws: law of inertia, law of momentum, and law of opposite reactions.
Okay, 3 laws are there. Okay,
Then we saw what is impulse, what are coincial forces, and that is the Lami's theorem, ma'am. And finally, we stopped with what are the 4 basic forces.
Yes, what are the types of forces? Okay, in this laws of motion, we stopped at the types of forces. So we can see only the contact forces now. Okay, in this one, non-contact forces not that much important for this laws of motion because we have to make some contact forces then. So what are the contact forces? You told so many types of forces in contact. First one is the friction. Is it right?
Yes, ma'am.
Okay. What is the friction formula? Friction force formula.
Formula is in on inclined plane or like what, ma'am?
Friction force is also one type of force that you know. What was the formula for that?
What kind of formula, ma'am? I mean, related to what, ma'am? Normal reaction.
Okay, that you don't know, I will tell, okay? That I want to teach you. Okay, so then the second one, what you told? The second type of contact forces?
Weight.
Normal force.
Okay, normal force. Then?
Applied force.
Applied.
Then the gravitational force or weight.
Okay. Gravity or weight?
Mechanical, ma'am.
Okay. Then?
Tension.
Spring.
Tensional. Then the seventh one will be spring force. Okay, so there are so many types of contact forces there. So the friction already we know that is act on the two bodies in contact. Okay, in contact only the friction forces will be added. The normal force means what? What is called as the normal force? Okay, normal means already we named that it was the 90-degree. Perpendicular, it's called as normal. Yes. But here also the same meaning is applicable. If I'm having one object, okay, this is my surface. This is my surface. In the surface, one object is having, okay, placed on the surface. That object having the mass m, okay. The mass is m. That m mass object is placed on the surface. Definitely what is having? The object will do the weight to the downwards. Yes or no? All the objects are the force. Okay, weight is the force. All are going towards only due to the gravity. Okay. அது வந்து கீழே போகாது கண்ணா பட் அந்த இருக்கிற இடத்துல இருந்தே அந்த ஃபோர்ஸ் வந்து டவுன்வர்ட்ஸ்ல இருக்கும் ஓகேவா the force of the weight is going downwards. I am telling the direction of the force only. Okay, the magnitude is not going down, the same magnitude, but the direction of force is going downwards with one weight. Okay, but the opposite to the weight force, it was the normal force. Opposite to the weight or opposite to the downward, that will be upward force. That force is called as the normal force, or it is called as the reaction force. Okay, you can write it one by one, then only you could understand what I'm telling. Okay, is it clear, my dear? Pavan, can you start your video? Pavan, Aravind, why it is what I have? Actually, my voice is little bit damaged. You could understand. I can't establish my voice. Okay, I can't loud it, speak loud. This is my voice. Okay, so please able to obey my words, Dakana. Okay, Aravind, are you clear with this one?
Yes, ma'am.
Yes. So in each and every body, okay, even the human beings are also having the weight towards the downward force only. Okay. So each and every downward force, there is the opposite force that acting upwards, that is called as the normal force or the reaction force. Okay. It is called as the two types. So the symbol is also called as N, otherwise R. Both are same only. Okay. Both are equal. Normal force N, reaction force R. Both are equal. Then applied force means we can give the applied force. Okay. External force. One table is there means, so we want to apply one force. Okay. Okay. That force, that is called as the applied force. External force. F is equal to MA. That is called as the applied force or external force. You can call it as the external. It is called as applied force or external force. Okay. Then the weight already, you know, this is called as the W is equal to mg. Weight is also one type of force. And then mechanical force means what? Mechanical force means?
Ma'am, potential and kinetic.
Potential energy is there, kinetic energy is there, but what happened in force?
Ma'am,
Potential force and kinetic force.
Yeah, that is the same. Okay, the same given by the kinetic energy. Kinetic energy of the body or kinetic energy of the object. Okay, the same thing is given for the force, mechanical force. And in our case, mechanical and applied force both are taking us equal, because applied force also applied by some human or beings or some objects with the help of the objects. The same thing, the mechanical is also in the meaning of the total potential plus kinetic energy that was done by the some objects or the human beings. Okay. Then the sixth one is tension. Where the tension? All of us, we are having the tension in one at places. I think now also you have a tension. Chemistry class is also physics class, etc. That is one tension. And another tension, we are doing school classes as well as the Guruji classes. That is one type of tension. So many tension is there. Then what is the tensional force now here? Is this the
Force
tension is
on
same?
the string, ma'am.
Force on the string. Where you see it in day-to-day life, the string. Sorry, the tension is applied.
Ma'am, instruments, ma'am. Musical
Instrument.
instruments.
Very good, very good. Musical
vehicles.
instruments. Where?
Vehicles.
Vehicles.
Bike, car.
Yes, my dear.
Measuring
Vehicles also.
newspaper.
Yeah, Karthik, tell me.
I'm measuring a newspaper weight.
Okay.
20.
And
That's what its name,
can you see the swing
Ma'am, outside in my balcony itself, ma'am.
outside in your balcony?
The cloth rope, ma'am.
Yes, very good, very good. That is also very good example. And in earlier days, okay, in childhood days, you play a swing, yes? What happened to the swing?
Yes, ma'am. Tension force. Yes, ma'am.
That rope, that was not the iron rope or anything, okay? That was one metal, okay? That I don't know what is that metal alloy, but that is also one tensional force is there in that swing. Okay, that swing tensional force is written in terms of T is equal to mg or T is equal to ma. Anything we can write, okay? But we can write mg only. Because all the rope towards the ground only, it can give the tensional force, okay? Or it is based on that one. That we can go with the problem. If the problem you can see means you can understood. But the formula is tensional forces T is equal to mg, okay? But the direction is differ. In a swing, you just imagine now you are in a string, okay? What happened to the downward force? Which one is the downward force?
Weight.
Weight. Then the upward force is what?
The normal.
Tensional force. It is not a normal force. At that place, the tensional forces will come, okay? For normal object, the normal forces will come. But you are in a one spring or one rope means, at that place, what happened? Downwards, it's your weight or the weight force. Upward will be the tensional force because the rope is there, okay? Rope, it is the rope is the only balancing you from the swing, yes? Other than what will happen? You can fall it down, yes or no? Without the tensional force, we can fall it down. So that two forces are balancing each other. One is the downward weight force. உங்களோட weight ஏத்த மாதிரி என்ன பண்ணும் அந்த tensional force வந்து நமக்கு கொடுக்கணும். Without giving the tensional force, we can't swing to and fro, okay? Are you able to understand this one? Okay, very good. Then the spring. What happened to the spring? Spring. Where you see the
Either
spring?
compress or expand the spring. That time it will.
Compress or elongation is there in that spring. Is it clear? Wherever you see the spring, in so many toys, we can see that.
Rubber band, ma'am.
Vehicles.
Rubber band, very good. For girls, it was the very best example is rubber band that I will tell. And for boys, it is pen and so many toys, small toys, the spring is there. Okay. Okay, so the same example, if two bodies are connected by spring, what happens? Two bodies or the two weights are connected with the one string, elastic string, what happens?
Ma'am, how much ever you elongate it, it will come to the same position.
Yes. So actually, in that spring, one is the elongation has happened, another one is the compression. The two things was happening in the spring. That was happened in each and every time. One is elongate, and again it will come to the compressed state. So these two states are combined to each other. So the spring force is combined or elongation. You can write this. Compression, okay? The name is compression and elongation. You can write the name as compression. So in the spring, I can draw the spring. So this is my surface. From this surface, I can have one spring, and from the spring, one mass is there means how the masses be? The masses go downwards or the masses go upwards due to the compression as well as the elongation of the spring. Okay. So how to write down the force equation for that one? It is not equal to same F is equal to ma. Am I right? For the spring, okay, for the spring only, the force will be differ like F is equal to Kx. F is equal to Kx or minus Kx will come. It is due to the direction. Okay. If it is elongated means the object will go towards the earth. At the time it is positive. It is compressed means what happened? The body moves that is upward. Yes, moves upward. In the time the upward direction is opposite to the gravity. At the time it is negative. Is it clear? So the positive and negative based on the direction of the compression and elongation of the string one. So what happened
what
to
is
the
this K and X, ma'am?
K is the spring constant, Rakanna. That is one constant. Okay. K is the spring constant. That problem each and every constant. Okay. Don't worry about that. This is nothing but whether it is elongation or compression. It defines any one. X is the distance of the elongation or distance of the compression. What amount of distance it elongated or what amount of distance it is compressed from the original position. So now this is my original position. Okay. So from this original position, this is the elongated position, or this is the compression position, means that was the X. Do you understand? That is also some distance. Are you clear with all the forces types?
Ma'am, I was not able to hear, ma'am. Can you repeat what you were telling
Okay.
before?
Okay. So I can tell one more time. First, all of you know about the friction. Yes, it is clear. The friction, actually, that friction will come with the another one new topic that I will come with later. Okay. But in general, you know the friction is happening between the two bodies with the contact. Okay. That is the main topic of friction. Then normal force. When the normal forces happened? When it was happened?
Ma'am, opposite to the frictional force.
Opposite to the frictional force?
The surface on which it perpendicular to the
yes.
surface.
For example, okay, for example, yeah, for the better example, I will tell, okay, Aditya, I think you are a visible one for me, better visible. You can have a table, yes?
Yes, ma'am.
On the table, you are having a paper or pen or a notebook, anything. Can you show me? Where is your notebook? Okay, just see, my dear, okay, all of you please see that. He placed his notebook on the table, okay? Is it clear, all of you? Yes or no? Just tell me yes or no.
Yes, ma'am.
Yes.
Is it tough to say yes or no? Huh? Okay, just see that the notebooks are placed on the table. Now the notebooks having the two type of forces. What are the two types of force? Can you tell me? What are the two types of force? One is the weight going downwards. Okay, the weight of the notebook. The weight of the notebook going downwards to the earth. Another one is the normal force. We can't able to see that two forces, but actually one is going downwards means another one is going upwards. That is called as the normal force to balancing that weight. Okay.
Yes, ma'am.
To balancing that equation or the balancing the force, we are providing the normal force or reaction force. Is it clear, my dear? It is not only for the object, it is applicable for all the things which is present in that world. Okay. Is it clear, Pavan? Do you have any doubt in this one? No. Are you clear with the normal force? All the object having the two forces. One is the weight that is going downward. Another one is the normal force that is going upward. Okay. And the applied force is nothing but the external force which is applied by ourselves or any external body. Okay. And gravity or weight, that is also same. W is equal to mg. And mechanical force is almost equal to the applied external force. And tension tension means that is the rope, okay, or any connected by the any rope, okay. So that is the rope or the spring, okay. It is not spring, it is one sting, okay. You can call it as the sting. Okay, violin, piano itself, not piano, violin. Yes, violin, guitar. In that one, the string was connected from one place to another place. In that also, the tension is making a main role for that one. Okay, namakku sound கேக்குதுலையா? From violin, from guitar, how we are able to hear the sound? How it is possible to hear the sound?
When we are applying
Vibrations.
Vibrations. Why the vibrations are happened? Due to the tensional force, because that
Yes, ma'am.
was
Yes,
in that guitar and violin, the tension was very high. Okay, because the two string or connected and the two end was very tightly, so that the tension was very high. Due to the high tension, they will produce the vibrations. So due to the vibrations, we can able to hear the sound of that, okay, instrument. So the same thing you can see for the spring. Spring means what? It is the elastic spring, okay. It was the elastic spring. When the body is connected with the spring means what happened? There are two options are there. One is the spring is get elongated. Another one is the spring get compressed. Okay, that two situations are there. So based on the two situations only, we can make the equations. Okay, is it clear, my dear? Okay, so
Yes,
if you are all completed or okay with this means, shall I erase this? And can we go with the next? All of you
Yes, ma'am.
completed your writings?
Yes, ma'am.
Or do you need to write again? Is it clear or not? Have you completed?
Yes, ma'am.
Yes, ma'am.
Completed, ma'am.
Yes. Okay. The next situation is very easy for you. Shall I erase it, my dear?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. So the apparent weight. The next one is you can write. Apparent weight of man in lift. This is very easiest one way to find out this apparent weight. So now you assume so many times we are going in lift, okay? You know how the lift is working, yes? How the lift is working, Dakarna? Can you tell me by using what type of force it is used in that lift? Pulley is there, okay? அது மட்டும் தான் இருக்கா? By using the pulley?
have a weight on the other side and then
Okay, you are telling that pulley, na? The pulley is rotating one side so that all the rope was rotating and
tension
the
force.
lift is going each and every floor like a 0, ground, 1, 2, 3. Okay, why it was happened? The pulley is rotating. The rotating is nothing but the mechanical force. Okay,
Yes, ma'am. It is applying the tension force on the
tensional
lift.
force is applied because due to the rope. Very good. So there are two forces here in this lift. One is the mechanical force due to the pulley and another one is the tensional force due to the rope. Okay, are you clear with this two forces? Okay, now you are in lift. Okay, if the lift was slowly upwards or slowly moving upwards from 0 or 1 second, okay, first, second, third, likewise, what happened to your weight? How you feel? Your weight is reduced or your weight is increased? How you feel?
Little bit more, ma'am. Like
Increased, ma'am.
especially when the lift
Little
is
bit
too fast, ma'am.
increased.
It will be increasing.
Little bit increased. Okay, the same thing if the lift was come back to the ground from the 4th or 10th floor, how do you feel?
Lighter.
Floating.
Decreased.
Floating.
You're on a lighter weight, yes?
Yes.
You feel we are in a less weight, yes? Likewise we
Somewhat, yes,
feel.
ma'am.
Okay, now just imagine this is not happen anywhere, but you have to think. Okay, you are in a 10th floor, suddenly the rope is cutted out. What happened?
As we start falling down,
கடகடன்னு
we
உள்ள
feel
போகும்.
like we'll just like, there's no weight for us, ma'am. Like, no weight at
There
all.
is no weight for us. We are on the floating stages. If it is suddenly falling means what happened, Rakana? Suddenly falling, like bungee jumping or other. Okay, அந்த மாதிரி நமக்கு வந்து fall ஆகுது என்ன feel ஆகும்? We feel we don't have any weight. We are floating or we are flying in a high place. Okay, So the same feeling was happen in that flight without any acceleration, downward acceleration. Okay. So that is the condition we have to see in a mathematical relation. Okay. The same thing we need to write in mathematical relation. Can we write like that? Okay. So are you able to understand what I'm going to tell? So first one is the upward acceleration is there means what is your exact weight? Downward acceleration means going downward. Okay. If it is there means what is your weight? And if it is no acceleration, only the free fall. Free fall means what? Only due to the gravity, the object is moving towards the ground. Okay. There was no rope and no anything. Nothing is there. Only automatical fall. That was free fall. If it is a free fall means how you feel. That we are going to write in the mathematical equation. Okay, the first condition. The first condition is lift is rest. How do you feel? The lift is at rest or moving with a constant velocity or moving with a constant velocity. How do you feel?
The normal.
Yeah, my dear. Yeah, Pavan, you can close your webcam, okay? But you can answer my questions, okay? That you can do now.
Yes, ma'am, I
Yes.
can do that.
Okay. Yeah, tell me, my dear, if the lift is at rest or it is moving with uniform velocity, at that time, what happened to our weight? Is there any changing whether the
No, ma'am, we'll feel same
No
weight.
change.
will feel the same? Yes, very good. So at that time, our weight is equal to same of mg. W is equal to the same mg. Okay. And the next one, the next condition is lift is accelerated upwards. Okay. At that time, what happened? Accelerated with the some acceleration g.
Weight is high.
Weight is high. So how can we write down that one? So W is equal to mg is there plus a is there. Okay, one extra accelerator is also there. Are you clear? What is that extra accelerator? The pulley. Okay. We have to pull that lift by using the rope. Na? That is one extra acceleration towards the direction upwards. So we can write m is the constant. So these two things are the both acceleration due to gravity plus one extra acceleration. We can write this one. Okay. M into g plus a. The third one is what?
Ma'am, how is M into G plus A coming, ma'am?
M into g is there, Dakarna.
Yes, ma'am.
Again, we have to add another one acceleration. That was the pull. So we have to add these two accelerations. M is the constant one. Only the acceleration was added, not about the masses. Okay.
Okay.
Again, the
No, ma'am,
same
suddenly it
lift is-
looked like you took comment, ma'am. That's why I asked.
No. Okay. So mg is our weight. In that weight, one extra acceleration is added means the acceleration term only be added. Okay. Not the whole masses. Acceleration term z la வந்து இப்போ 9.8 இருக்குன்னா plus how much amount of the acceleration? So acceleration is 5 we are giving means 9.8 plus 5 only you are added. Are you clear? That's why I'm writing here. Okay, like this. G plus one extra acceleration. How much amount of acceleration you are given that? The same thing you are in a downward direction from a lift. So the same downward means what I have to write?
mg minus a.
minus A.
Minus
Very
A.
good. M of G minus A. So from the gravity, you have to subtract the original acceleration which is acted on the lift. Okay. Aditya, do you have any doubt? Naveen,
Just trying to comprehend
Aravind?
it, ma'am.
No, ma'am.
Okay, dear. Aravind, Karthik, Gopikrishna, all of you completed up to this? All of you
Yes,
writing or
ma'am.
not? Okay. So
Writing,
the
ma'am.
lift is fall freely. The fourth condition is fall freely.
Your voice is breaking now for me.
Okay, is my voice is clear to you, all of you?
Ma'am, it was breaking.
Ma'am, your voice is
It's
breaking.
okay now, ma'am.
Breaking.
Okay now, ma'am.
Now it is okay, na?
Yes, ma'am.
Yes. Okay, dear. So it is fall freely means what happened?
From MG, ma'am, simply.
mg.
No. Fall freely means what? At that time, the gravity is equal to the acceleration. Yes, gravity is equal to the acceleration. So fall freely means it is the downward direction. Am I right? Fall freely na inna enga pogudhu mela pogudha illa keela varudha. Again it going towards
Downward.
the downwards. So the what is the equation of the downwards? G minus A. So what is my condition? G and A is equal means how can you write?
The weight is 0.
W
Zero.
into 0. So it is also 0. Our weight is look like 0, but it is not actual 0. Okay. We
Apparent
feel
weight is 0.
apparent weight will be 0. Okay. Are you clear, my dear? So fall freely means the condition will be equal to the gravity. Due to the gravity is also equal to the acceleration. So what is our downward equation? So once the lift is accelerated downwarding means my equation is W into G minus A. Okay. So in that equation, I have to apply my condition like Z is equal to A. If it is both are equal means, both are subtracted means it will come 0. So my finalized answer is also 0. Is it clear? Or do you have any doubt? Yes or no, my dear?
How do we take weight into G minus M? That alone I couldn't understand.
Okay. How do you take weight is equal to Z minus A? Okay. So first of all, what is our weight? W is equal to mg. Is it right?
Yes, ma'am.
Okay. And we are in the lift and the lift was taken upwards or taken downwards by using the one rope. Okay. So that rope was accelerated by one pulley. Yes. And the pulley
Yes,
வச்சு தானே rotate பண்ணுவாங்க. So that
Yes, ma'am.
acceleration is called as A. Okay. So this is
Yes.
accelerated of pulleys. Okay. The rope accelerated. So once it was the lift is going upwards means what happened? Upwards means with our weight, we have to add this extra acceleration. If it is downwards means with our acceleration, or sorry, with our weight, we have to subtract the acceleration. Okay. With
Yes.
our weight, we need to subtract the acceleration. So this is also acceleration. So this is also acceleration. So where the difference will get only in that acceleration term, we get the difference. Okay. We didn't get any difference in the mass. Mass is same. Okay.
Yes.
That's why we are giving the relation like m into z minus a. Now, at the condition of free fall, the both condition is what? G is equal to a. At the time, what happened? My weight is equal to 0. Okay, this is called as the, okay, this fourth one is called as the weightlessness concept. Weightlessness concept. Okay. Please understand this is very, very important concept in each and every question. Weightlessness concept. When the weightlessness concept is arrived? When the concept is arrived, Akana?
And the apparent position is 0. Apparent weight is 0.
Aye, not like that.
When the body is in free
Ma'am,
fall.
object is free fall.
When the object is in the free fall, the weight will be 0. Tell this condition, the object is free fall. At the time, the condition is what? Acceleration is equal to the acceleration due to gravity. So that only our weight is, or the apparent weight is equal to 0. That is what it is called as the weightlessness concept. Is it clear, my dear?
Yes.
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 1 minute. I can give one small problem for you. You can do it and let's see the next two problems. Okay, my dear. All of you tell me, all of you completed this page?
Yes, ma'am. Yes, ma'am.
No, ma'am.
All of you means all of you can tell yes or no.
No, ma'am.
No, ma'am.
No, ma'am. Aditya, you are taking this
Yes,
much time to write?
No, I was trying to understand what is.
I think I saw that. Aditya, he follows that. First, he need to understand what I'm telling. Then he needs to write what I'm writing in this one. Yes, Aditya? Are you right?
Yes, ma'am.
Are you clear with this concept now?
Yes, ma'am.
Okay.
Yes, ma'am.
So for understanding and for writing, we can't provide the time for each and everything. Okay, already I told, if it was given for understanding and for writing and for discussing means, we will go up to 9 or 10 o'clock. That will happen. Okay. I think for Aditya only, I want to take up to 10 o'clock. It's right. I think so. What, Aditya? Are you ready?
Ma'am, I'm okay with it, ma'am, but
Yeah, okay. But I'm not okay because I just low with my network. Actually, now itself my GP was over. I think I was with another hotspot. Okay, I'm just making this class. I think you are having a connection, Wi-Fi connection you have in your home, all of you, or fiber.
Yes, ma'am.
yes, ma'am, fiber, ma'am.
You are using the fiber, yes. That was you are using the school classes and Guruji classes and test so many things. Yes, very good. Okay, how the fiber is working, Dakana? Anyone knows the process working principle? Yeah, tell me, Aditya.
Ma'am, not exactly how it works, ma'am, but light signals are used to pass through the fiber wire cables, ma'am. The fiber cables will first have lots of protection, ma'am, then insulation, ma'am. Then inside one very thin glass or some transparent tube will be there, something like that.
Okay.
Then the light or radio waves or something. I don't know, ma'am, but that light
Yeah,
waves
yeah,
will
yeah.
pass through it, ma'am. And that way we can communicate in the speed of light, ma'am.
Yes.
So it
But
is very
not only one single light rays, there are so many light rays are there. How we can get the so many light rays in a one single tube? You are telling one some glass particles are there inside that material, yes, tube. What happened if the glass materials are
Some
there?
vacuum like conditions.
Vacuum or anything?
Maybe just particle kind of, I mean, very, very good question.
In
Different
fiber, we have
frequencies, different frequencies
actually
of light.
the fiber is like one tube. Okay, in this tube we are having so many nano fibers like this wires, or we can get likewise. Have you seen this? The cross symbols. Actually, this is not.
Spiral, 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 ma'am.
Likewise, it can go so many times. What is that spiral things? There are two types of fibers. That is the band fibers. This is not a band. I think I forgot this name. This is what we are using nowadays. The geo fiber, or actually so many times. Band fiber. Okay, band fiber is less used than that of this. What does this means? You know about that total internal reflection?
Yes,
Yes, ma'am.
That was used in this one. The total internal reflection was happen in all the places and come to that one. Okay, but here we didn't have the total internal reflection. That was the power is very less. But here the total internal reflection is happened, so we can get the highest power or high network. Okay. Yeah, this is what I'm just telling what the working principle of fiber. So I will give the problem. Is it right, my dear? All of you completed this page?
Yes, ma'am.
Meenakshi, are you clear with this one? Naveen,
Yes,
Karthik,
ma'am.
Gopi Krishna, Aravind?
Yes, ma'am. Yes, ma'am.
Okay. This is the one simple problem. Okay, you can do it.
Ma'am, after writing, can you read the question once, ma'am?
Yes, my dear, sorry. I want to try to change my habit, but it is not happening.
No, ma'am, it's clear, ma'am.
And
Some
everything.
letters alone.
Yeah, okay, okay. Even after the question, I also don't know what I'm writing here. That was also happened so many times. Okay, so the force of 50 Newton acts in the direction. Okay, I can draw the picture here. The block of mass 5 kg resting on a smooth horizontal surface. So you need to find out the acceleration of the block. Okay, that was the same.
Frictionless plane, no? Frictionless plane, no?
Friction.
Friction.
Yeah, my dear, frictionless plane one. So this is 5 kg. You can see here one extra point is given. That force is acting as 50 Newton and the degree of acting is 60 degree. Then you need to find out.
Which direction acceleration? This side.
Yeah, you can see here.
Okay, ma'am.
Okay, I will come up with the 1 minute. 1 minute, you can do it. Are you finished, my dear? You finished?
Yes, ma'am. Yes. Ma'am, yes.
What is your answer?
I just send in the chat, ma'am.
You go take points, the horizontal direction. Yeah, Aditya, can you tell me how to solve this? How you solve?
Vectors. So, 1 second, ma'am. I'll just remember how I solve. Ma'am, the angle is given in the vertical plane, ma'am. So to find the horizontal component, we use the sine component, ma'am. So we get the horizontal force as 50 sine of 60 degree.
Yes, the same.
And then we can divide by the mass, so we get the acceleration.
Sine of 60 degree is equal to force. Am I right?
Yes, ma'am.
This is called as the force. So this force is equal to mass into acceleration.
Yes,
So 50 sine 60 is what?
the horizontal component.
Sine 60 is what?
Sine 63, root 3 by 2.
Okay. Mass is 5 kg
5 kg.
into acceleration. So from this one, we have to find out the acceleration. What is the way?
Ma'am, directly force is equal to mass into acceleration. We can't use, ma'am.
Here the angle is given, Rakna. By using that angle only, we can able to do it. Otherwise, we can't able to given the answer. Okay.
Why that sign, ma'am?
Why the sign means you have to take. Okay, one body is there. You just neglect the body. Likewise, you have to imagine. You just neglect the body, okay? The body is there, but the horizontal we need to find out means what is that? What is the sign?
Ma'am, why to find the horizontal, ma'am?
Because we have to find the horizontal acceleration.
That's what I meant.
Horizontal force, horizontal surface is mentioned here, and the body is also in that horizontal surface, and on that body only we are providing the force. Okay, so the force is what? F is sin theta only it will came. You know that, Kanna? Okay, Aditya, can you explain one more time? So all of your friends need to understand.
And
Just tell with one example. Just now you are having your notebook. That notebook is a mass. You are providing one force that is for 50 Newton in that angle of 60 degree. And how you could identify it was a sine 60 degree.
ma'am, we learned about finding the x component and y component of any vector, ma'am. So since this force is a vector, ma'am, and we got the angle at 60 degree with the y-axis, ma'am. And so if we want to find the x-axis, the angle is with the y-axis, ma'am. So y will become the cos component. So we have to multiply with cos to find y, ma'am. I mean force in y, ma'am. And to find force in
Actually,
x-axis,
you already know here the x and here the y. Okay.
That's why multiply the same.
Here it is what? F cos theta. In this one, F sin theta. That already you know, yes? Like, நம்ம இதுல பார்த்தோம் இல்லையா oblique motionல u பார்த்தோம்ல u is there, u cos theta and u sin theta. Are you clear with this one?
Yes, ma'am.
So now the same thing, if it is there, this is the u, okay? This is u and this is u cos theta and this is u sin theta. We provide in that oblique motion. Now what happened? This is the x-axis, this is the y-axis means now where the angle is given. Where the angle is given.
Angle is given with the y-axis, ma'am.
With the y-axis. So we want to find out that. So find out the forces.
Ma'am, how did we
F
know
sin
this
theta.
going with the y-axis, ma'am? Force.
Angle, Dakana, you can see the angle is not provided here.
Okay, ma'am. The figure is given, ma'am.
The figure is given.
Okay.
That's why I'm telling.
Okay.
I am drawing the figure. Okay, based on the figure only you need to understand. Are you able to get my point? To understand one simple concept, it takes 5 to 10 minutes. What I'm going to take okay, wait. I can redraw one more time. The same thing. But you can see this is my x-axis and here the force is given at the angle of 60 degree. So where the angle is there, now you can see where the angle is there. So this is F means, how can you write? F cos x, sorry, F cos theta. Is it right? And here, this is F sin theta. Are you clear? This is the way we want to write down. Naveen, Aravind, Praveen, Karthik, all of you able to understand just on your video, my dear? On your video and attend the class, okay? So, instead of F, you were seen in the U, yes? Oblique motion, we were seeing the U, initial velocity, that was in horizontal U cos theta, in vertical U sin theta. The same thing we are applied here. F is in the horizontal, yes, F cos theta, in the vertical, F sin theta. But now, we were giving the force in that angle of 60 degree to that y-axis. It is not given here. If it is given here, means we can use cos theta. Okay? Are you clear? So that force is given to this direction is F sin theta. So F sin theta is equal to MA. So what is that F? 50 Newton and sine 60 degree is equal to 5 into A. Are you clear now? So the answer will be, acceleration will be 5 root 3 ms power minus 2. Is it clear? Or do you have any doubt?
This derivation I understood, ma'am. Only one doubt. Why are we finding that x value, ma'am? That
Why we are
sin
finding
60, that length, ma'am.
Yeah,
of
that is the
person.
angle is given in that figure itself. If you see the question means that question itself, they given the diagram. Without the angle, we can easily find out. F is equal to
No, ma'am. Is
MA.
this a particular formula or something? 50 that mass into angle. Or
What's
Ma'am,
that mass into angle?
no, she's asking F cos theta if that is the one particular formula, ma'am.
Yeah, that is there already. We discussed in
Ma'am, we
object
learned this
motion.
in position vector, ma'am.
Position
Notes, ma'am,
vector.
like last
How
week.
can we find out that cos theta and why the x component having that cos theta and why the y component having the sin theta? Yes, already we learned, Neha.
no, ma'am. That I understood. I'm just asking why to find that x this.
Why to find out the
No,
f
ma'am.
sin
I got the
equal to
answer.
MA.
I got the answer. I
No.
understood.
Tell me. What is your mind? Can you tell me?
No, ma'am. I understood. I got the
What do you
answer.
understand? What do you
Ma'am,
understand
like
and
I
what do you-
had the doubt, like why it is applied on the text, ma'am.
Okay.
That sin 60 I take, ma'am. Why to use that sin 60? I was not understanding.
Why to use the sin 60 means already they written or they given in the diagram itself. Sin 60 degree, based on the 60 degree, the force is driven. Okay. Or the force is given.
Yes, ma'am.
Without
I
the diagram.
understood that. No, I understood.
Okay. So without the diagram is how you find? The diagram is not given. If the no diagram is means, what do you understand? No diagram is given, then what do you understand?
If no diagram is given, means we will
10 meter per second square.
50 Newton is in this direction, ma'am. If diagram
Yes,
is given,
F
means
is
we
equal
can-
to MA. Only the values F is equal to MA without the diagram. But the diagram is given as in the question itself. Okay. Yeah. That is the only one problem we need to see here. And the next one. Okay, the next one we can go with the theoretical one. Shall I erase it, my dear?
Yes, ma'am.
Okay, ma'am.
Okay. Yes, my dear. Yes, Aditya, you are right. Okay. We need to find out the horizontal component. Okay. So for that only we are finding this one. Do you have any other doubts in this question? Okay. Okay, the next one is the motion of the bodies. Okay, motion of the bodies in and connect body. This is very, very important. Based on that only so many problems have came in loss of motion. And we know Neha and Meenakshi, you see videos of the loss of motion, and in that one also you couldn't able to understand this one. Yes, I think this is the portion you didn't understand. Motion of sorry, not connected bodies. Motion of bodies in contact. Okay. In contact means this is one surface. Just realize this is one surface. In this one surface, I am having two objects. Like this is my mass number 1. This is like mass number 2. Okay. If the two objects are there and my external force will be in this direction of M1. What about Neha and Aravind? Naveen, where is your video?
Ma'am, your voice is actually breaking. That's why I switched off the video.
Yeah, my dear. Okay. So this surface is what? Frictionless surface only. Okay. Don't see that the friction is happen in that surface as well as the mass. Okay. Don't think like that. So I am having a two masses. One is the mass 1. Another one is the mass 2. And I am applying the external force to where? I am applying the external force to where? From this diagram? Can you tell?
Mass 1.
Mass 1 க்கு நான் வந்து force apply பண்றேன். Okay, I am just applying the external force to mass 1. Okay, what is my force equation? In general, what is the force equation?
MA. F is equal to MA.
Okay. So now the same F is equal to how many mass we are having?
2.
So M1 plus M2 into A. Is it clear? Aravind, all of you on your video and write it the same Drakarna. If you don't understand any simple concept means you can tell me, okay? F is equal to M1 plus M2A. Now from this, what is the acceleration? What is my acceleration from this equation? F by m1 plus m2 is my acceleration. Okay, very good. So this is my first formula, acceleration. Then you can easily understand one small forces are there in between the mass 1 and mass 2. Am I right? Is it clear or not? Now, you just assumed you were in school. Okay. You were in school means how you placed in your school. You were placed near to your friend or near to your very close friends. Yes. On the time, how you placed you and your friends, there was a very gap. No, there was no gap in between you and your friend. So definitely what is there? In between one force is there. That was the one friction force in between you and your friend. Am I right? So அப்படிதானே நம்ம எல்லாம் உட்கார்ந்திருப்போம். In class with friends means we are even வந்து அவங்க மேலேயே கூட நீங்க போய் உட்காருவீங்க. ஓகேவா? That is not our duty, but we are having a one small friction force with the friends. The same thing, the mass 1 and mass 2 having some frictional force or the mutual force in between them. Okay. So that I can write as a F. That I can write as a F, small f. So small f is the one frictional force in between the two masses. Are you clear, my dear? So in between the two masses, one small force is there. What is the small force? That is called as the friction force between M1 and M2. Okay. Now, what is that F? How do you find out? What is that F? How do you find out? Tell me fast. No. Okay. So that frictional force is also written in terms of that force and mass. Okay, the same thing. Now, acceleration the same method we are going to write down the one small friction force or the contact force. You can call it as a contact force or friction force between the mass 1 and 2. Okay, so first the external force will go to where?
M1.
M1. So in this concept, the direction of the force is very, very important. Okay, so please able to understand. The external forces will go to M1 and the M1 is gathering that force. Okay, நம்ம கொடுக்கிற force என்ன பண்ணுது? Gather பண்ணுது. Then what is they doing? It just transfer the external force to where? The next board. Yes. So the external force first I'm going to mass 1 and the mass 1 enna pannu? So first you have to take Meenakshi and Neha. Okay, because only 2 girls are there in my class, so I'm just using 2 girls only. Okay, so Meenakshi and Neha, I'm just giving the notes to Neha. Okay, this class notes giving to Neha. Neha, what you are doing? Also your classmate. Able to clear my voice here?
Ma'am, it is breaking, ma'am.
Breaking.
1 minute. It is clear?
Now it's still breaking for me.
Now it is okay. Now it is clear. I think it was clear now.
Yes, now it's clear.
Yes, now it's clear. Okay. So first I'm giving the notes to Neha means. See what happened. She is also giving the same notes to Meenakshi. Okay. So the same thing is happened for here also. So the forces, external forces given to the mass 1. But the mass 1 is contacted with where? Mass 1 is contact with the mass 2. So definitely it contact or it will give the force to M2 also. So where the force is given? From M1 to M2 தானே போகுது. Yes or no? So in between M1 வந்து யாருக்கு கொடுக்குது? M1 வந்து அந்த force யாருக்கு கொடுக்குது? M1 is giving the force to where?
M2.
M2.
M2. And what is giving? The force is given. Divided by how many number of mass is given here?
2.
2.
Two
So
masses.
M1 plus M2. So this is called as the contact or the frictional force in between the two masses. Are you clear? So only two masses are placed here. The first mass is given the force to the second mass, that is the M2 into F, divided by the total number of mass. Are you clear with this one? Is it clear, my dear? Okay. The same thing you can understand or you can write for the three masses. This is M1, M2, M3, and my force is also given to the M1. Then there are two contact force or two frictional force. One is M1 and M2. Another one is M2 and M3. Is it right? So you can write F1 is the contact force in between M1 and M2. F2 is the another contact force in between M2 and M3. Then what is that and what is the acceleration of this one? Can you able to find out? I think this is one the toughest one for you, okay? But you have to learn this one. Take it fast, my dear. Have you understand or not? Is it clear? First, it is
Ma'am,
very
we have
easy
to
for
find
finding
the
the force.
frictional force, ma'am.
Yes, frictional force between M1 and M2 and frictional force in between M2 and M3. Okay.
Ma'am, so it is 2M2F by M1 plus M2 plus M3, ma'am.
What do you tell? I think I'm also confused with your answer. What you are telling?
No, ma'am. Should we add both
Tell me,
the answers, ma'am? I'm asking.
Okay, so first, the first system is clear. Only the two objects or two masses it is clear. So ஒன்னும் இல்ல கண்ணா, இப்போ நான் வந்து என்கிட்ட வந்து ஒரு ஃபோர்ஸ் கொடுக்குறாங்க, ஓகேவா? அந்த ஃபோர்ஸ் நான் என்ன பண்றேன்? I am just giving to my object which is connected with me. Okay. என் கூட யார் கனெக்ட்ல இருக்காங்களோ அவங்களுக்கு நான் என்ன பண்றேன்? அந்த ஃபோர்ஸை வந்து ஃபார்வர்ட் பண்றேன். So which is forwarding here? The force is forwarding to where? The M2. So I'm just forwarding the force to the M2. So I'm writing M2F divided by the total mass. Okay. The same thing you can come here. So what is the acceleration of the three particle system or three mass system? What was my acceleration?
F by M1 plus
F
M2
by
plus
M1 plus M2 plus M3.
Very good. M1 plus M2 plus M3 is my acceleration. Okay, so what has happened to F1? F1 is the contact force in between M1 and M2. Yes? அப்ப பாருங்க, இந்த force first யாருக்கு போகுது? M1 க்கு போகுது. M1 is given to that and M2 is given to the same force. Okay. So F1 is what? Is the contact force in between M1 and M2. அப்ப M1 யாருக்கு கணக்கு கொடுக்குது?
M2.
M2, ma'am.
இத பார்த்தே சொல்லிடல. M1 M2 க்கு கொடுக்குது. M2 க்கு F கொடுக்குது. Okay, M2 யாருக்கு கொடுக்குது?
M3.
M3. Okay, that's it. The same M1 plus M2 plus M3. Or you can write M2 plus M3 into F divided by the same mass. M1 plus M2 plus M3. Are you clear? So we want to see M1 and M2. So M1 யாருக்கு forward பண்ணுது? M2 வந்து யாருக்கு forward பண்ணுது? M1 is forwarding the force to M2 and M2 is forwarding the force to M3. Okay. That was happening in contact because there was one contact means it definitely sharing the force to all those particles. Okay. That was the sharing of force in between. That's why I'm writing this time. Okay. இந்த மாதிரி எழுதுறதுக்கு ரீசன் என்ன? There was a sharing of force in between the particles or masses. Okay. ஒன்னும் இல்ல கண்ணா, for the best example is you are having so many bulk of matters, okay, in a one single array. In a one single array, you can have so many things. Or you don't go with that also. நம்ம cycle stand பார்த்துருக்கீங்களா? Cycle stand or bike stand or car stand வராது. Bike stand or cycle stand பார்த்ததே இல்ல நேஹா. At least in example or movie பார்த்துருக்கீங்களா?
No, ma'am. Cycle stand seen, ma'am.
Cycle stand means in all in only one single place, all the cycles are standing. Yes, in a row by row. So one cycle was slapped or one cycle was moved or fall down means what happened?
Chain reaction.
All the cycles or fall down. Why it was happen? நான் தள்ளி விட்டது ஒரே ஒரு சைக்கிள் தான். ஒரு சைக்கிள் தானே விழுந்திருக்கணும். Why it was?
No, ma'am. The first cycle will transfer the force on the second cycle. That will transfer the force.
Yes.
Chain reaction.
Here also the same concept. Chain reaction or the sharing of the force. Yes. Shall we call it as the sharing of the force? Now தள்ளி விட்ட அந்த force வந்து second cycle க்கு forward ஆகுது. Then it is forwarded to third cycle. Then it is forwarded to fourth cycle. So likewise, the force is forwarded to all the cycles which is present in the place. Are you clear, my dear?
Yes,
is it clear or not?
Yes, ma'am.
The same thing, instead of the cycle, here the masses are connected. So if I'm given one force mass, the second mass also affected, little bit affected, okay? Not that much affected, but little bit affected by the given force. The same thing, the three masses system. If you are having a three masses, the first given force is the mass 1 is affected, but mass 2 and mass 3 is less affected by the mass 1, by the given force, okay? Rather than the M1. Are you clear with this concept or not? Do you have any doubts or do you have any doubts in this one? Meenakshi, Neha, Naveen?
No, ma'am. We're finding the frictional force F1 and F2 now, ma'am.
F1 and M2
So,
is there.
Is that frictional force between, because ma'am, M1 and M2 are not moving with each other. They are just together, they are connected and moving with the ground, ma'am.
Yes.
So the friction force should be between the mass and the ground, ma'am.
No, it is a frictionless surface.
Ma'am?
It is a frictionless surface. Just the object is there. The object is there in the same position. But the friction force in between the masses, two masses.
Ma'am, but then M1 is not moving, sliding over M2 or anything like that.
Moving, moving. Yes. If we give the force or if we pull the object, definitely it will move on the surface, okay? Are you able to understand?
Ma'am, like for example, these are my two masses. Ma'am, I'm pushing them, ma'am.
Yes.
So friction will exist if they are moving like this, ma'am. But then since they are not moving anything like this, there should be, the friction force should be zero now between them.
No, my dear, no. I'm not asking the friction force, just the contact force. You are having the two objects, yes? In the two objects, it is contacted. It is touched together.
The normal force between each other, ma'am.
That contact force is what? The another name of contact force is friction force in between the mass 1 and mass 2. That is what I'm telling, okay? So friction force means if the motion of the object is done, the surface, okay, on the surface means we have to find out the friction force also.
Ma'am, will it be the friction force or the normal force that this one exerts on this?
Ma'am.
Prana, are you able to hear me?
Now, yes, ma'am.
Yes, ma'am.
Yes. Yes, my dear. Yes. Sorry, one call is came. So due to the call, it was not connected. It is disconnected. Okay, my dear, that was the, I'm telling there is no frictional force. Okay, the frictional force will go into zero, but I am asking the contact force in between the two objects. Okay,
Ma'am, so is that
the
the
same two
normal force
objects
that
you are
this
having them.
exerts here? Ma'am, the normal force that this
Yes, we
exerts
can
on,
tell
is it that? Ma'am?
normal force is always exerted in the upward direction. Upward direction. Okay.
Ma'am,
So
normal force
in the
between
object
these two, ma'am.
this is the you can tell normal force between these two. That is why it is called as the contact force. Okay. That is why it is called as the contact force. Have you understand, Neha, Meenakshi, all of you able to understand this concept? Arvind, Gopi Krishna, Naveen,
Yes, ma'am.
or it is
Yes,
tough
ma'am.
to understand?
No, ma'am.
Yes,
Okay.
I hope it was tough to understand. Okay, so like I have to take okay, just you need to see I'm just going with the three objects. Okay, M1, M2, and M3. So I'm just given. So first you have to take the two objects. M1 is giving the force to M2. Is it right? With the contact. அது கான்டாக்ட்ல இருக்கணும்னு என்ன பண்ணும் M1 வந்து ஒரு ஃபோர்ஸை வந்து M2 க்கு கொடுக்கும். At the same time என்ன பண்ணும்? Due to the action and reaction, Newton's third law, every force there would be equal and opposite forces there. So அதே மாதிரி என்ன பண்ணும் M2வும் அதுக்கு தேவையான ஃபோர்ஸை வந்து கொடுக்கும். So then only these two masses are in contact. Are you clear? It was clear or not, my dear? Okay, well, then
Okay.
M2 is connected with the M3, so it is given one force, that is the contact force. At the same time, M3 is also given to the M2. Okay, so this is the contact force. This is the contact force F2, this is the contact force F1 that we want to find out with the numerical value. Okay, so here my F is given to the mass 1. So that M is given to M2, M2 is given M1. Are you clear? This was clear to you? Then what was the value of F1? F1 is the force between the mass 1 and 2. So mass 1 is given to the force to mass 2 and mass 2 is given to the force mass 3 divided by M1 plus M2 plus M3. So can I write that M2 plus M3F? Yes or no, my dear?
Yes, ma'am.
Yes. So this is what my contact force in between M1 and M2. What is that F2, Rakanna? Anyone? F2 is the contact force in between M2 and M3.
Yes, ma'am.
What will be the answer?
M3
First M2 பாருங்க, M2 யாருக்கு கொடுக்குது, then M3 யாருக்கு provide பண்ணுது. Share பண்ணும் இல்லையா, the force will be shared. So just imagine this was a cycle, okay? Just imagine this was a cycle. So cycle க்கு ஒரு force கொடுக்கும்போது அந்த M2ன்ற cycle வந்து யாருக்கு கொடுக்கும் next force?
M3.
M3 க்கு நம்மளோட force கொடுக்கும். But M3 யாருக்கு கொடுக்கும்? Is there is any other
M2.
cycle?
No. No
friction.
other cycles. No other cycles near. Okay. இது வந்து டைரக்டா இப்படியே தான் ஃபார்வர்ட் ஆகும். ஓகேவா? Don't confuse with Meenakshi. I think you confused the inner forces. Yes?
Yes.
You are confused with the inner force. That inner force is called as the contact force. But நம்ம கொடுக்கிற external force வந்து எப்படி மூவ் ஆகும்? It is moving forward one. So the best example is cycles தான். ஓகேவா? நீ ஒரு சைக்கிளை தள்ளி விட்டேன்னா என்ன ஆகும்? All the cycles are repeatedly fall down. So that was the same case here also. Once I'm giving the force to one mass means the same force is going forward to all the masses. So what is happening? M3F by M1 plus M2 plus M3. This was my F1 and F2. Do you have any doubt on this force? F1 and M2? Sorry, F1 and M2? No. All of you just tell me, Dakarna.
Ma'am, if I give force directly to the first object itself,
already first object only we are giving the force.
No, ma'am. From the first object to second object we are giving, ma'am. to the first object itself we give the force means, what will be the formula?
To the first object means, I didn't understand. To the M3 you're asking.
No, ma'am, to M1 I'm asking.
To M1 only we are giving the force now also.
Okay, but
what is your point of view? I think your point of view is different from mine. Okay, can you tell? What is
no,
your
ma'am,
point of view?
got it, ma'am. I just misunderstood.
I
thought
also
like,
want to know that one.
no, ma'am, I
You
thought
got
like
what?
to from M1 to M2 we are transferring. No, ma'am. So if some object transfers to M1, we have to include M1 plus M2
Yes,
plus M3
yes, definitely. If some object is transferred, the force means that object mass is also included here.
Okay, that's what I wanted to clarify.
Yes. Here we are including the force directed towards the mass one. Okay, not any masses is included. So only the force is included here. So now, can you tell what is happening in the force is given to this direction? If the force is given to this direction means what is my, this is called as F1 and this is called as F2. What is my F1 and F2? Anyone?
F1 will become M1 plus M2.
You can same the name. No. The same mass M3, M2, M1. The mass is same. What happened to F1 and F2? This is not very tough. Okay, it is very easy.
Ma'am, F1 will become M2 plus M1
M1.
into F, ma'am, and divided by M1.
So F1 will become, instead of M2 and M3, what happened?
M2 and
M2
M1.
and M1.
And M1 will come. Okay, very good. And F2?
Just M1. M1.
M1F. Okay. Are you clear with this one?
Yes, ma'am.
If you are having any doubt in this one, the black color letters, that is the second case. The F is given to the third object, mass 3. So mass and if it is given this likewise, the reversing order is forward. Have any doubt? Do you have any doubt in this one?
No, ma'am.
No. Okay. So this is what we have in the connected bodies or contacted bodies. Okay. Now the body is connected by a string, connected by a rope. What is there? Are you clear with this one? If you are clear means, can you write down as this?
Yes, ma'am.
The second case. Second case, you can write it. Okay. Second case, the F1 will be equal to M2 plus M1F divided by M1 plus M2 plus F3. And the F2 will be M1F divided by M1 plus M2 plus M3. Karthik, Pavan, Gopi Krishna, all of you, just start your video, my dear. I want to know you're there or not.
Start the video. I can't hear you. Video is
Okay, dear, you can write it. You can write it. You can complete it first. All of you completed?
No, ma'am.
Yeah, make it fast, my dear. Is it clear? Yeah, my dear. Yeah, is it visible? Okay, so I want to erase this one. Can we go with the next step? Yeah. So now the contact, the bodies are in contact means you know, yes? You know how to write it and how the force is shared between all the masses. Are you clear with this one? Do you have any doubt in this, the contact bodies? Do you have any doubt? Means just tell me, my dear.
No doubt, ma'am. That one.
All of you? All of you just tell me if there is any doubt. No doubt. Okay. So now you can see the motion of the connected bodies. Connected bodies means each and every body should be connected by it's one spring. So here itself, I'm just giving the 3 bodies, okay? So first we have to give the 2 and then 3. So I'm just giving the straightly to the 3 body system. M1, M2 and M3 is connected by one string or one rope, okay? It was connected with one string. So what happened? String is connected means what type of force is there? Other than the external force.
Tension force.
Tension force.
Yes, very good. So tensional force 1 is present in between M1 and M2. Tensional force 2 is present in between M2 and M3. Are you clear? Do you have any doubt? அங்க நம்ம வந்து என்னது கண்ணுக்கு தெரியாத ஒரு கான்டாக்ட் ஃபோர்ஸ் இருந்தது. இங்க நமக்கு தெரியுது. Tensional force is there. So tensional force is there in between mass 1 and 2 and tensional force is there in between mass 2 and 3. Okay. Okay. So what is the acceleration of the same? Acceleration, how can you write?
F by M1 plus M2 plus M3.
The same. F by M1 plus M2 plus M3. Okay. So what is the tensional force formula, Kanna? What is the T1 and TF? The same. What you followed in that contact bodies. The same is given for the connected bodies. என்ன அது நேம் மட்டும் தான் மாறி இருக்கு. அங்க F1 சொல்லுவோம், இங்க T1 சொல்றோம், அங்க F2 சொல்லிருப்போம், இங்க T2 சொல்றோம். That was the difference. The name only different, but you need to find out the T1. What is there? Here the mass 1 have the tensional with the M2 only, okay? But M2 mass is having the tension force with the both. Do you get my point?
Ma'am, one
Yes or
doubt,
no?
ma'am.
Yes.
Ma'am, is the force provided on M1 or is it provided on M3 in that direction, ma'am?
Force is provided on M1.
Ma'am, is it in this direction or this direction, ma'am?
This direction only, my dear. Can you see? This direction only.
If it is a string, ma'am, M1 will go till M2 without letting it move, ma'am. How can the force be? Ma'am, M1 and M2 are connected.
Sorry, my dear. Sorry.
Oh.
I just confused.
Okay,
1 minute.
Okay.
Yeah. Actually, the same thing as yeah. Now it was clear. It was connected with that M.
Okay, ma'am.
Now it is clear.
Okay, ma'am.
So now you can see M1 have a string force between the M2 one. It doesn't have this side. இந்த பக்கம் எந்த ஒரு கான்டாக்ட் ஃபோர்ஸுமே கிடையாது. Okay. But you can see the M2 have a 2 string force. Okay. 2 tensional force. One is due to M3. Another one is due to M1. The same thing. The M3 is having one tensional force due to M2. Another is one external force. Can you tell what is the T1 and the T2? T1 is what? I want to find out the T1.
T1 is M1A.
M1F.
By
The
M1.
same force is traveled in each and everywhere. The same thing, my dear. Do you know? M1F divided by M1 plus M2 plus M3. You can see T1. T1 is present here in between M1 and M2. Okay. Are you clear?
Yes,
T1 is the tensional force that is present in between M1 and M2. So what I'm going to do, I just wrap the mass 3. Okay. And just pull the mass 3 towards the force direction. Okay. So what happened? This pulling is affecting that mass 2 as well as this pulling is affecting the mass 1. Likewise, you have to understand. So இப்போ நான் இழுக்கிறேன் இல்லையா, தேர்ட் மாஸ் நான் இழுக்கும் போது நான் இழுக்கிற ஆப்ஜெக்ட் மாஸ் 3 மட்டும் வந்தா பரவாயில்ல. அது என்னோட வரும் சேர்ந்து மாஸ் 2 வரும், மாஸ் 1 is also combined with that string. So if I'm pulling the mass 3, not only the mass 3 is came.
So M3
So
plus M2.
along with that mass 3, mass 2. M2 plus M1 is also came. But what is the tensional force in between? Tensional force 1 is present in between M1 and M2. So M2 when the provide the tensional force, it's providing the M1. So M1F divided by M1 plus M2 plus M3. And T2. So what is happening to the T2? T2 is the tensional force in between mass 2 and mass 3. So now you tell me, mass 3 is providing the tensional force to where? Mass 3 is providing the tensional force to mass 2. Very good. And mass 2 is providing the tensional force to where?
Mass 1.
So the same. Last in the same equation is also present here. Are you clear? I think this is a bad topic, okay? It is a vast and idu nama padichona namakke satyama thooka vandrum, okay? And madri oru topic, okay? But we need to understand what has happened inside the forces and inside the bodies. Are you clear, my dear?
Ma'am, can you please show which direction on the string that force is acting, ma'am? Like T1 and T2, which direction?
Yes. T1 and T2 direction, it will all the direction. That is, mass 1 providing the tensional force to mass 2. At the same time, the mutual M2 providing the same tensional force to mass 1. Contact force over mass over mutual force provide one. The same thing, mass 2 will provide the tensional force to mass 3. At the same time, mass 3 is also providing the same and opposite direction of the tensional force to mass 2. So if you are seeing the direction, you definitely confuse the direction of the external force. Okay. That's why I didn't give any direction of the tensional force. Are you clear, my dear? Is it clear for the 3 systems connected with the string? Okay, so then you can find it. Okay, this is for you. You can find it. I think you can easily find out this one. Okay, can you see these 2 objects? Yes. Okay. The first condition is I am having a 2 objects that is 1 by 1. Okay, in a upper direction. So the best example is in your table. You are having the so many books 1 by 1. Yes. Nama books la adiki vechirupom 1 by 1. Adhe ninga example eduthukkonga. Okay. So there are 2 books. So one is the larger book, another one is a small book. So I am giving the force to the lower book that was the present on the surface. So at the time, what happened to the contact force as well as the acceleration? What happened? And if I'm giving the force on the object on that or another object B, okay, that was the A. So if I'm giving the force to A object, what happened to that? My acceleration and force. Okay. So this is for your homework, Kanna. You can do it. And this is the time for making test. Shall we go for it?
Can you please repeat the what you have to do in the homework? I did not get it.
Actually, for doing this homework, you need to understand the friction. Yes. So can I tell the friction? Yeah, I think the friction is very easy for that. It will take 1 more minute for doing the friction. Okay, so if friction is finished means you can do this homework. Shall we go for the friction, Kanna? The friction is very, very important. Or you can learn friction by yourself.
Okay, ma'am, we'll go to friction now.
Okay, you can learn friction yourself. Okay, you can learn the friction, laws of friction, and the theorem of friction is there. and how to find out the angle of the friction. That is all the theory particles, okay? Theory part. And what I'm going to tell means, likewise, you have to see in one diagram in your problem or anywhere. So this is the surface and this is one sliding plane. So in this plane, my object is come to that ground. Okay. This is my situation. Okay. So this is the ground or surface. In that ground, or track and the track we have to get the objects. One, by using the sliding plane, we are getting the yes. Situation is understanding by you or not? Can you tell yes or no, my dear? Then only we can finish this
Yes,
class.
ma'am.
Yes. So on the sliding plane, I'm going to pull my object. Okay, I'm going to pull my object. That object is having mass m. Okay, then what is this force?
Normal force.
The upward is the normal force. Okay. The downward is, what is the downward?
Ma'am, the
mg.
downward is gravitational, ma'am.
mg.
mg is right, but actually mg eppadi kanna work out agum?
mg cos theta.
Straight to the ground. Yes.
Towards
mg
gravity.
is actually towards gravity is there. Okay, this is called as mg. So this is x-axis and this is y-axis, means here mg cos theta is applied and here mg sin theta is applied. Okay, two directions. That is, one is for x-axis mg cos theta, y-axis for mg sin theta. But what is the vector direction? Mg is the vector direction towards the ground. That is the due to gravity. Okay, are you clear with this one? So body வந்து slanting la irundhalum nammaloda gravity எதை நோக்கி இருக்கும்? Towards the earth. That is the straight vertical line. Okay, it is not slanting. That already you know. Yes. Yes or no, my dear?
Yes, ma'am.
So the gravity force is acting vertical direction. So it is mg and mg cos theta, and opposite to mg cos theta, that was a normal force. And what happened to this one in this direction?
Ma'am, do we have to stop it, ma'am?
Where the karna?
Ma'am, this block is sliding down, ma'am. So should we stop it so that it doesn't slide?
No. This was pulling that object from this direction of mg sin theta. Okay.
Okay, ma'am.
So if one object is moving, means in that opposite direction, what is the force is there? In each and everywhere.
Friction.
That friction is there. Okay. So in this you are pulling the object towards the ground. So once the object is pulled, means adukku opposite direction enna force irukum? Friction force irukum. Okay va? That already we know. Neha, can you tell what is the real reason in your mind? What do you think about this concept? Is it vague?
Ma'am, understood. Ma'am.
Understood only. But I think you are tired. For
No, ma'am.
no.
I'm
Aravind,
just trying
Naveen,
to class.
try to classification. Okay. Meenakshi, you are also tired?
No, ma'am.
Yes, sir. No, solradhukku confused ah irukku. Okay.
I am tired.
Okay, so this was the diagram of the friction or free body diagram.
Okay, ma'am.
Okay.
One doubt.
Yes, my dear. Yes, tell me.
The small ma'am, you told the which one is facing down, that is x-axis and y-axis now in this
Yes.
diagram.
Yes, yes.
How do we determine that, ma'am? That x-axis and that is only y-axis.
X-axis and y-axis is based on that only, Dakarna. So now you can see. Actually here we are having the x and y. Okay, in this
Yes.
horizontal base. The same thing is reversed, means what happens? In this case, you are having the mg here and mg cos theta is here, mg sin theta is here. Is it right?
Yes, ma'am.
And the same thing is reversed, means what happens? just reversed or rotate downwards.
Becomes upside down.
Becomes upside down. So it is X and it is Y. Am I right?
Yes, ma'am.
So இது வந்து நார்மலா நம்ம பார்க்கும்போது இருக்கிறது. இதே இப்படி vertical கொஞ்சம் ஸ்லைட் பண்ணி பாத்தீங்கன்னா எப்படி தெரியும்?
Yes, ma'am. Yes, ma'am.
இப்படி கொஞ்சம் ஸ்லைடிங்ல போச்சுன்னா என்ன ஆகும்? This is X axis and this is Y axis. Is it right?
Yes, ma'am.
That is the way we are given. This is mg. This is mg cos theta. This is mg sin theta. Is it clear?
Yes. Yes.
Because my plane is sliding plane, Rakana. It is not a straight horizontal plane. This is sliding. So that only my axis is also a little bit sliding. Okay.
Yes.
But original axis is there. This is the original axis.
Yes. Yes.
X, Y. But konja slide agumbodhu enna our axis is also sliding like this. Okay. Do you get this point?
I don't know.
This is very, very toughest concept, my dear. Okay. You need to understand this concept very well. If you have any doubt, you can ask me. And by using this only, okay. And I can tell the formula for friction also. F is equal to mu into R. Mu is the coefficient of friction. R is the, already you know, it is the reaction force or normal force. So the product of coefficient into the reaction force is nothing but the frictional force. Okay. So please write down this one. Coefficient of friction is the constant. And actually the force, friction force is directly proportional to the reaction force.
This is the maximal friction force possible, ma'am.
Yes, my dear, yes.
Ma'am, this
Maximum
formula
amount
is
of
for
friction is
finding the
called as
maximum amount of friction, ma'am.
எல்லா ஃப்ரிக்ஷனுக்குமே ஒரே ஒண்ணுதான். Friction force is equal to mu into R. Actually நம்ம R ன்னு என்ன சொல்றோம்? வெயிட் ஃபோர்ஸ்க்கு ஆப்போசிட்டா இருக்கிறத நம்ம R ன்னு சொல்றோம். எஸ். அதே மாதிரி இப்ப நீங்க ஒரு பாடியை வந்து புல் பண்றீங்க ஆர் புஷ் பண்றீங்க. அப்ப அதுக்கு ஈக்குவலான அமௌண்ட் ஆஃப் ஃபோர்ஸ் தானே நம்ம வந்து ஃப்ரிக்ஷன் ஃபோர்ஸ்னு சொல்றோம். Is it clear? That is the way it is correlated. Okay. Do you get my point? If my pulling the one body towards my side means the opposite side, the friction force is there. That was the one tendency of resist the body. Yes. Yeah. That has happened in the opposite direction. So F is directly proportional to the R. That was I'm giving one constant for satisfying that. It is called as coefficient of friction. Is it clear, my dear?
Okay, ma'am.
Yeah. So actually, yeah, fine. Tell me.
Can you explain coefficient alone again? Coefficient of friction.
Coefficient of friction is nothing but it is only one constant here. Actually, F is directly proportional to R. Okay.
Yes.
F is the friction force. So to neglect the constant only, we are providing one constant, like spring constant. Likewise, we have to provide one constant. Okay.
Yes.
Yeah, my dear. Yeah.
Yes. Thank you.
Okay. So this is the time of test. Can we go for the test? Yes or no?
Okay, ma'am.
Yeah. Please take your notebook.
Second, ma'am.
Yes, very good. A minute. Can I erase this? All of you had an idea about this? Is it clear? Do you have any doubt in this concept of the friction? If you have any doubt, means just tell me, my dear. Naveen, Karthik, Gopi Krishna, all of you on your video to write the test. This is mandatory now. Already you know this one. Actually, I want to ask some questions. Okay, instead of writing that one, I want to ask the questions to all of you. Because I have a minimum amount of time period. Okay, if I want to give the questions and I have to write means again it will take time. So here I'm just giving the oral question. Okay. Okay, centripetal force. Which one provides the centripetal force? My question is, Which one? First, who will answer the Kanna? Can you tell your name?
Ma'am, where, ma'am? Which one
Ma'am,
provides?
fourth.
Where, ma'am?
I can give the option, my dear. Who will answer the question?
Me, ma'am.
Yeah, who will answer?
Karthik.
Karthik. Okay. So electron is revolving around the nucleus. Okay, don't see this one. You just hear my question. Okay. Only that what I can stop my video. Yeah. Okay, Karthik, can you able to hear my voice?
Yes, ma'am.
Yeah. So I can give two examples where you have a what a centripetal force. So what provides the centripetal force in the following? Electron revolves around the nucleus and the earth revolves around the sun. Which one provides the centripetal force in that following cases? One the cases electron revolving around the nucleus. Already you know all of you on your video, my dear. Pavan, Naveen Kumar, Aravind. So which forces provide the centripetal force in this following cases? Anyone knows me, just tell me, I will give the mark.
That electron around the nucleus.
Electron revolving around nucleus means which force providing that centripetal force? Centripetal means it is revolving in a circular, yes?
Electrostatic force.
Yeah, very good. Electrostatic force. Then the next one is earth revolving around sun. Karthik. Second question is Neha. Aditya. Naveen.
Earth revolving around sun, ma'am.
Okay. Earth revolving around the sun, which provides the centripetal force?
The sun. From the sun.
This is the student. Only 8 students.
Yes, ma'am. Only 8.
Yeah, okay. Tell me. Which force Earth is revolving around the sun? Edu help பண்ணுது centripetal workout ஆகுறதுக்கு. That was the easiest force.
Gravitational.
Gravitational force. Very good, yeah, very good. So you're getting 2 marks. Then, Neha, you're the second person. Sorry, I just write your name fast. Okay, why a cyclist has to bend inwards while going on a circular track? Why a cyclist? Okay, cyclist, you know now. Why the cyclist has to bend inwards while going on a circular track? நிறைய இது பார்த்துப்போம் இல்லையா மேட்ச்லாம் பார்த்துப்போம் yes the bike race so bike race
Ma'am, bend inward means
அந்த bike எல்லாமே
towards the side, no, ma'am. Towards the curve, no, ma'am.
Towards the curve. Yeah, bend பண்றாங்க. Why?
Ma'am, when you go in a circular
you have to tell the reason.
Ma'am, if I tell it theoretically, it's enough, ma'am. I don't know the exact words.
No. Just tell me what you understand. ஏன் நம்ம வந்து இப்படி bending, what happened?
Ma'am, it is basically done to stay in the correct path, ma'am. So when you go in a circular motion, there's a tendency to go tangential to that circular path.
Okay.
So when bikers turn inwards, ma'am, they are able to curve their path and come onto the right track.
Yeah, very good. So to provide the centripetal force for that one, yes, you are trying to convey that one.
Yes, ma'am. I don't remember that term.
Right. Yeah, centripetal force தவிர மத்த எல்லா tangent எல்லாமே நீங்க clear-ஆ சொல்லிட்டீங்க. So due to the tangent only we are turned inward. Yes, very good. And Aditya, your question.
Yes, ma'am. Yes, ma'am.
Yeah, wait. It was very easiest question. What is the effect of air resistance in time of flight and horizontal range? What is the effect of air resistance in a time of flight and horizontal range?
Ma'am,
already you know in oblique motion.
If there is air resistance, then the horizontal range will be less, ma'am.
Okay. What about the time of flight?
Ma'am, the time of flight will be 1 minute, ma'am.
Air resistance நமக்கு கிடையாது ஓகேவா நம்மளை பொறுத்த வரைக்கும்
Yes, ma'am.
we didn't consider the air resistance, but if the air resistance in one effect means what is the horizontal range and what is the time of flight? I think the horizontal range will be less, okay,
Time
right?
of flight
And what is the
will
time of
be
flight?
more, ma'am.
Yes, absolutely, it was right. Without air resistance, it was easily come to the ground.
Yes, ma'am. It will come to the
But
ground, ma'am.
with the air
But yes, ma'am.
resistance,
The
it will
ground, I mean,
long.
the
It
air will
will
provide
take
upward
so much
resistance.
amount of
It
time.
will take some time, ma'am.
Yes, my dear. Yes, very good, very good, very good. And next, Naveen, are you there?
Yes, ma'am.
Naveen?
Yes, ma'am.
Yes. Okay. Body have constant velocity and still have a varying speed? Can a
Ma'am,
body
what?
have a constant velocity and still have a varying speed? Varying speed, I know the body is having a constant velocity.
No, ma'am. Because-
Varying speed, any object having constant velocity.
No, ma'am, it's not possible.
It is not possible. Why? Why is your answer is no?
Ma'am, because velocity is related to speed.
Velocity is related with the speed. So once the
So
speed is
once
varying,
speed varies,
the velocity is
velocity
also.
will vary.
Okay, so I want to ask one more question because this is very easiest question you can answer easily. Okay, name the quantity which remains unchanged during the projectile motion. Which is unchanged. Name the quantity which remains unchanged during that projectile motion. We have so many components.
X particle.
X-axis. That is a horizontal component. Very good, very good, very good. Super. And then Meenakshi, are you ready, my dear?
Yes, ma'am.
Okay, where is can a body have zero velocity still accelerating?
Ma'am, can you repeat, ma'am?
Can a body have a zero velocity still accelerating?
No, ma'am.
No. Okay, it is no. I'm accelerating.
Ma'am, your voice is breaking, ma'am.
Yes, my dear, 1 minute, 1 minute. Yeah, I think it is clear. My voice is clear now.
Now clear, ma'am.
Okay. Meenakshi, tell me.
Ma'am,
can a body have a zero
velocity
velocity
only,
still?
no, ma'am.
Velocity is zero, but
So
still accelerating.
acceleration.
Now only
Ma'am,
you have
is
to
it
think the
still
acceleration.
No, ma'am, I didn't understand your question. It's still accelerating, ma'am.
Still accelerating.
Ma'am, velocity zero and still accelerating, ma'am.
Yes.
Ma'am, I'm not getting you, ma'am.
Accelerated is not only only one acceleration is there, yes? Another
Yes,
acceleration is also there. What is that?
Gravity, acceleration due to gravity.
Then what happened?
So acceleration will be there, ma'am.
இப்ப சொல்லுங்க acceleration is there, ma'am. நானே ஆன்சர் சொல்லிடுவேன். அதுக்கு நான் வந்து மார்க் பண்ணுமா?
Ma'am, I was hearing like velocity zero, ma'am. Body is accelerating, ma'am. Then you are asking me whether it's accelerating or not, ma'am. Like that only I understood.
Accelerating means the body is there, so the body is accelerating.
No,
mg
ma'am,
is there, the rate of the body.
You told that the body is accelerating and you are asking me whether it's accelerating. So that's it.
Okay. The next question for you. A quantity has both magnitude and direction. Is it necessarily a vector?
Yes, ma'am. Yes, ma'am. Ma'am, can you hear me, ma'am?
Magnitude and direction. Yes, my dear. Quantity has both magnitude and direction. Is it necessarily a vector? Vector இருந்தா தான் quantity வந்து magnitude and direction இருக்கணுமா?
Yes, ma'am.
Yes, but my answer is no. My answer is no. Okay. Why? Why?
Ma'am, don't know, ma'am.
So if it is a vector means, obey the laws of vector addition. Okay. If it is obey the laws of vector addition. So do you think the current is there? No. Current is scalar or vector? Current is scalar or vector? Current.
Scalar.
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 Yeah.
But it obeys the laws of vector addition.
How, ma'am?
Okay. So that type of questions we can see that one. Okay. Meenakshi, your another one more question. What is this? If you are telling this one means I can provide the mark. Okay. And you have to find it and tell me. And
Ma'am, are you drawing something, ma'am?
A cross B and B cross A is what?
Okay.
Okay, next Pavan, are you there, my dear?
Yes, ma'am, I am there.
Okay, can you tell the examples
Ma'am,
of
should
scalar
I say
and
the
vectors?
answer, ma'am?
Yeah, you could say the answer. Pavan, can you tell what is the examples of scalar and vector?
Current is scalar, ma'am. And what to say?
Okay.
Moving
Okay, so
north
I can give
and moving
wait,
northeast.
I am giving some terms. Can you define which one is the scalar and which one is the vector?
Yes.
Okay, can you define which one is the scalar and which one is the vector in this?
Instantaneous velocity is vector quantity.
Okay, vector quantity.
And area is scalar quantity. Area is scalar quantity.
Area is scalar. Okay.
And the frequency is also scalar, I think. Frequency is also scalar.
How do you tell area is scalar?
Because area doesn't have anything to do with direction.
Doesn't have any direction, clearly.
Yes, ma'am.
Aditya, Megha, what is your opinion? Area doesn't have any directions.
Ma'am, it is vector, no, ma'am, but even if it doesn't have.
Ma'am, area is scalar.
Because
only.
we found the vector using, we found area using vector, no, ma'am.
Area is a vector quantity, my dear, okay?
Yes, ma'am. How?
Area is also having the directions.
Which way, ma'am?
That was called as the pseudo vectors. Okay. It is actually not a vector, but it is also a vector. Okay.
Yes.
You understand? Now, if நம்ம சொன்னோம் இல்லையா current வந்து scalar தான். But அது வந்து law of vector addition க்கு obey ஆகும். So that is called as the pseudo. அதாவது பொய்யான வெக்டார்கள்னு அர்த்தம். Pseudo means that is not real, it is imaginary. So the same thing, area in general, area doesn't have any directions, but the law of vector addition is obeying for area. So that it is called as the vector.
What is the law of vector addition?
Vector addition means yes, the theorem of parallelogram vector addition, rectangular vector addition, likewise there. Okay. So law of vector addition is there. Based on that vector addition, we are telling this area is also under the category of vector. Okay. Yeah. So Pavan is getting 2 marks. Then Aravind, are you there, my dear?
Yes, ma'am.
Aravind?
Yes, ma'am.
Yeah, Aravind. Okay, okay, dear. Okay. So 1 minute. Can you hear me, guys?
Ma'am, your voice.
Yes, ma'am.
What is the my dear. What is the angle between direction of velocity and acceleration at highest point of trajectory of the particle?
Ma'am, can you repeat?
Ma'am, your voice is breaking, ma'am.
breaking.
What is angle between directions of velocity? Okay, direction of velocity means what? This is my direction of velocity. Okay, and acceleration at the highest point. So what is the angle between
Your voice
this
is
one?
breaking. I can't hear you, ma'am. Can you repeat that?
Is it clear or not, my dear? My voice is clear or not?
Now it's clear, ma'am. Before it was breaking.
Okay, so what is the direction between the angle of velocity and the acceleration at the highest point? It is very easy.
Ma'am, once
Tell
again,
me.
can you repeat the question?
What is the angle between directions of velocity and acceleration at the highest point? In this highest point, okay, in this highest point, velocity is
Yes,
there,
ma'am.
acceleration is there.
90
So what is the yes, my dear, yes, very good, very good.
Okay.
Okay, next Gopi is there. Gopi, are you there, my dear?
Ma'am, yes, ma'am.
Yes. Okay, what is mean by circular motion? Circular motion and centripetal force. What is that? The formula of centripetal force? Tell me, my dear, fast. Can tell me fast, Jakanna. Gopi, are you there or not? Otherwise, I won't give any mark to you.